Yeah, welcome to the engineer mechanics. Now we'll start the third part of force. Okay, so force, as we all know, that is, it is an external agent which produces motion or helps to make motion, or it can retard the motion. Okay, that means it can make the body at rest. So what is free body diagram actually? Free body diagram is nothing but we draw the reactions and the other forces in a body. That is, it is the purpose of this to free the body from all other objects and surfaces around it. So here, if you see in this diagram, a person is standing on a ladder inclined at an angle, with the both horizontal and vertical. So in this position, what are the forces acting? So if you go for the free body diagram, we see that this is the position of the person. Okay, the force is acting, will be acting this force. So this part is, from this part is 1 meter, and from this part to the center of gravity. So gravitational force, it will be acting at the middle of this ladder. And this part, you see, this part is the frictional force. Frictional force is acting on the horizontal part. That means if it helps to body, that means it retards the sliding motion. That means if the ladder wants to slide this one, so friction force will act, ultimately it makes the body at rest, which helps in not sliding. So this one, from here you see that for the weight of this one, for this weight, so one normal reaction will be acting in the upward direction, and due to this support, because this ladder is hanging on this part, so one more normal reaction will be acting in this part. So these are the free body diagram and the forces shown here. So ultimately the weight of the man along will be your total weight. So this multiply this weight this mass multiply the center of gravity. So what are the process of constructing the free body diagram? The first step is to make the body isolated from all other surroundings. So first we have to give the most attention. So what is the part of the body and what is other part? That means surrounding part. Then we have to draw the external forces and moments which acts on the body, and the forces or moments which do not directly act, that should be not included in the free body diagram. And also the internal forces which are acting on the body should not be included. Then the gravitational forces. So gravitational forces, if it is not noted, the mass of the object will be the gravitational weight force applied to the body. So if we multiply this one with 9.81, we'll get the weight in Newton. So this weight will always acting downwards towards the center of the earth, and it will act at the center of the mass of the body. So if you analyze this one, so you can see that this is a body box of weight 60 lb, in pound it is given. So this is the center of mass, Fg is acting. So if we find out the actual weight, if we multiply then 60 into 9.1, we get the 588.69 is acting, is the actual weight of the body acting downwards. So normal forces, there are, I already mentioned that for every reaction there will be some normal forces which actually helps to prevent the body to occupying the same space at the same time. So what happen? An body in direct contact can exert normal forces with another object or surface which is perpendicular to the surfaces in contact. Again I am reading, an object which is in contact with another subject or surface, it experiences a normal force which is perpendicular to the surfaces in contact. So in this figure, if you see, a ball is standing on an support. As soon as it is actually, this support is at a right angle triangle. So what are the forces acting on the ball? So if you analyze, this part is acting at 30°, so this part, and this part is 60°. So if you analyze this figure, the free body diagram will be like this. So normal force Fn will be acting, this is the 30°, so normal force is acting on this, that means it is tangential to this body, so 30°. Again from this, if you analyze this part 60°, so if you draw the free body diagram, the normal force will be acting like this. That means these are the two forces, and the gravitational force Fg is acting downwards. So one more figure I'll explain here. So this is the joint or connection. So these are some roller support, and this is the fixed, and this is without roller support. This bar is standing on this surface. So what will be the forces, or what will be the friction force, normal force? I'll just explain. Here if you see in the left side in this figure, so this roller support actually helps the rotation of this body to this part, left or right, but the normal reaction and the vertical direction prevents motion in upward direction, normal forces. That means motion will be fixed, only the rotational motion will be there. And in the center, if you see, the normal forces in the x and y direction will prevent the motion in all directions. And in this fixed support, in the right hand support, you see it is fixed, so normal reactions in the x and y direction will prevent the motion of this bar in all direction, as well as moments as well. That means it will be fixed. Here mr is the reaction moment which prevent rotation in all directions in this figure. Third one. Next we will study the friction forces. Friction forces, as we all know, when a body slides one another body, the body which slides through that body, that other part of the surfaces, it will exert some forces in the opposite direction so that the body will not slide. That means up to a certain point the frictional forces comes into effect. At a certain value of frictional flow, the forces which were acting, it will equal. When that force limits the maximum amount of frictional forces, then the body will be sliding towards the other surfaces. So the friction forces always act perpendicular to the surfaces in contact. So there are some assumptions which can be considered during analysis of the friction force. So for smooth surfaces, there will be no friction forces. For rough surfaces, there will be some frictional forces relative to one another. So in that case, the friction force is always high enough to prevent the sliding. So for example, in this figure, if you see this smooth surface, there will be only one normal reaction. That means it can slide in this direction. So rough surface, if you see, it has the normal and this friction force also acting this. So that means this body will be raised. For the smooth surfaces, we are considering generally normal force perpendicular to the surfaces, but for rough surface, we assume normal and friction force both are present. So next one is a tensions in the cable. So how we can find out? So cable wire rope, everything is when attached to a body, it exerts a tension on the force body, and it tends to pull the body in the direction of the cable. So these ropes, cables, and other laser cannot be used for pushing, so they are always used for pulling the body. So we have a thorough knowledge about how the tension acts on the rope, wire, cables, etc. If you see this, this is one light. Is suppose this is the street light. The tension in the other parts, this one, if you see, at is acting at an angle 25 degree to the horizontal, and this part in the this part of the cable is acting at an angle of 15 degree to the horizontal. So if we find out what are the tension T1 and T2 here, so the tension force always acts in the direction of the cable, and it always tries to pull the forces. But these forces are the common, that means the T1, but some other forces like pressure from fluids, spring forces, magnetic forces, it also may be there, and it may act on the body also. So yeah, if these forces can be identified and added to the fluid diagram, the last step is to find out the dimension and angles on the diagram. So using this value, we can finally find the value of the forces which we have to find out using the free body diagram. So this is the most common and the used free body diagram when we are in simple purposes. So there are a lot of free body diagrams happening due to the forces reactions acting on the body. So we can study these parts by analyzing the forces, what are the main forces, so it acting on the body, excluding the surrounding one. So like this we can obtain the free body diagram, and from this we can analyze the forces, different forces acting on the body. So thank you.